When we're working with linear functions or linear equations, usually we see our equations written in what's called slope-intercept form, y equals mx plus b. We call it slope-intercept form because it tells us our slope, our m, and it tells us our b, our y-intercept. But if we look here at this paragraph really quick, it says the slope-intercept form, y equals mx plus b, has the advantage of being simple to remember and use. However, it has one major disadvantage, and here's why it is not always super useful. We have to know the y-intercept in order to use it. And a lot of times we're not given the y-intercept. A lot of times we are given the slope, and we're given just a random point on the line. So if we don't have our slope and our y-intercept, we're going to have to use a different formula instead of our slope-intercept formula to help us find that. And we call this formula, the one we're going to learn today, the point-slope formula. And it's named appropriately. We use it when we're given our m, when we're given a slope, and when we're given any point on the line. And we're going to call that point x1, y1. So this point-slope formula says this. It says y minus y1 equals m times x minus x1. Those things I highlighted in green right here, those are the pieces that we are given. Those are what we're going to substitute into our formula to write the equation of the line. And I want you to pay attention to the instructions here. Like on example 140 compared to example 141. 140 says write the equation of the line through this point and this slope. Okay, 141 says write the equation of this line through this point with this slope in slope-intercept form. So this tells me that I want my final result of that second example to be y equals mx plus b. It does not specify on this first one. If you want to convert it to slope-intercept form, you can, but it's not required. It just says to write the equation of the line. And keeping it in point-slope form is just fine if it only tells you to write the equation. Okay, so let's label the pieces that are given to us. It says we want to write the equation of a line that goes through the point 3, negative 4, that's x1, y1, with a slope of 3/5. So we're going to take those values and plug them in here, here, and here. So we've got y minus y1, y minus negative 4, equals m, our slope, times x minus x1, or x minus 3. Okay, I went ahead and wrote minus negative here. Usually when you see that, we're just going to go ahead and change it to y plus 4. So that's the equation of our line. It does not specify that we need to convert it to slope-intercept form, so we can leave it y plus 4 equals 3/5 times x minus 3. Okay, 141, we're going to do the same thing. I'm going to go ahead and write the point-slope form here. Again, we're replacing this piece, and this piece. Here's our x1, here's our y1, here's our m. So we've got y minus 2 equals our m, negative 2/3, times x minus negative 6, or x plus 6. Okay, if we want to convert this to slope-intercept form, I'm going to start by distributing that negative 2/3. So I've got y minus 2 equals negative 2/3 x. Negative 2/3 times 6 is going to give me negative 4. All right, for this to be slope-intercept form, we need our y alone. So we're going to move over that minus 2, and we do that by adding 2. So we end up with y equals negative 2/3 x minus 2. This is our equation, and now it's converted into slope-intercept form. Okay, example 142. Notice what's different here. They tell us to find the equation of the line. Again, they don't specify if it needs to be in slope-intercept form or not, so we don't have to convert it if we don't want to. But they didn't give us our slope here. All they gave us is 2 points. But we know that if we have 2 points, we can find our slope. And the way that we do that is using our slope formula. Slope formula says our change in y, or y2 minus y1, over our change in x, or x2 minus x1. So we're going to do that first. We have x1, y1, x2, y2. So to find my slope, draw my fraction bar. I've got negative 3 minus 5 on top, the change in y's. 4 minus negative 2 on bottom, or 4 plus 2 on bottom. So on top I get negative 8, on bottom I get 6. We can simplify that, and our slope is negative 4/3. That's our m. Our slope is negative 4/3. Okay, so now we're going to use our slope. We're not finished here. Our goal is to write the equation, so I'm going to use my slope, negative 4/3. And I'm going to choose whichever point I want. It doesn't matter which one we do. I'm going to use the one with a little bit, so I guess they're not even that much smaller numbers. So you can just eeny, meeny, miny, mo if you want. We're going to use those values, our m, our x1, and our y1, to plug into point slope formula now. So we have y minus 5 equals m, which we just found, times x minus negative 2, or x plus 2. They don't specify that we want this in slope-intercept form, so if you want to stop here, you can. Okay, a couple more examples of this. Same thing here, we're given 2 points, we're not given our slope, so we're going to go ahead and find our slope first. I'm going to do this over here on the side. I have m equals y2 minus y1 over x2 minus negative 3, or plus 3. If we simplify the top, we get negative 6 divided by 2, or we have a slope of negative 3. All right, so let's use our slope that we just found. Let's pick whichever point looks easier. I'm going to use this point right here. Now we use our point slope formula. We have y minus y1, y minus negative 2, or y plus 2, equals m, which you just found, times x minus x1, or x minus negative 1. We can write that x plus 1. Okay, notice this one does tell me we want this in slope-intercept form. So we don't want to stop here. We want to go ahead and distribute that negative 3. So we have y plus 2 equals negative 3x minus 3. Okay, to isolate our y, we're going to subtract 2 from both sides, and we end up with y equals negative 3x minus 5. And that's our equation in slope-intercept form. Okay, and then the last one here, it says find the equation of the line through the points 6, negative 2 and negative 4, 1 in slope-intercept form. So we're going to start out with the point slope formula, then we're going to convert it to slope-intercept form. Let's find our slope first. We have y minus y, 1 minus negative 2 on top, negative 4 minus 6 on bottom. And if we simplify that, we get 3 over negative 10. So there's our slope. Choose whichever point you want. I'm going to go ahead and use this point. Now we're going to plug this into our point slope formula. We have y minus y1 equals m, negative 3/10, times x minus x1, x minus negative 4, or x plus 4. Okay, to put this into slope-intercept form, let's distribute, and you're going to notice that this one doesn't turn out quite as nice as our other ones have. We have y minus 1 equals negative 3/10 x. Negative 3/10 times positive 4 is going to give me negative 6/5. We're going to add 1 to both sides to isolate that y, and we end up with y equals negative 3/10 x. Negative 6/5 plus 1 is going to give me minus 1/5. So this one would be a little bit more difficult to graph using slope-intercept form, but that's the equation of the line in slope-intercept form. So now we know how to write the equation of a line if we're given our slope and a y-intercept, or if we're given our slope and a point. Or in this case, if we're just given 2 points, and that's using our point slope formula.